Hey everyone, today we are going to solve the daily LeetCode challenge of 12th March 2024. And the problem statement is remove zero sum consecutive nodes from linked list. So let us first understand the problem statement. So according to the problem statement, we have been given a linked list. And what we have to do is we have to delete consecutive nodes that has a zero sum. Now, what do I mean by this? So let's take an example. Say for example, we have a linked list as 1, 2, -2, and 4. So if we get a part of linked list that results in zero sum, then we have to delete it. So here in this linked list, you can see that this part of the linked list, that is 2 minus 2, they are giving us a zero sums because 2 plus minus 2 is what? It's 0. So what we have to do is we have to delete this part of the linked list, correct? So our answer would be 1, 4. So we have to return this linked list. So what we have to do is we have to first identify the part of linked list that is giving us a zero sum. And once we have identified the part which is giving us a zero sum, what we have to do? We have to delete that part. Okay. Now we are having two questions, that is how to identify the part of the linked list, that is identify part of linked list that has a zero sum. Okay. Firstly, let's see how are we going to identify the part of linked list that has a zero sum. So for that, we will be making use of prefix sum. Let's see how. So we took the example as 1, 2, -2, 4. Correct. So initially our prefix sum is 0. So let me write here prefix sum. So initially it would be 0 and we would present at this node 1. So now what would be our prefix sum? It would be 1 plus 0, which is what? Which is 1. So our prefix sum will get updated to 1. Now our prefix sum would be 1 plus 2. So 1 plus 2 is what? It's 3. So we will get a prefix sum of 3. Now we are present at this node. So what would be our prefix sum? It would be 3 plus -2, right? Which would be 1. And then we'll move to this node. And what would be the prefix sum? It would be 1 plus 4, which would be 5. Correct? So here you can see that this prefix sum 1 is repeating itself. Okay. So whenever a prefix sum repeat itself, it means that all the elements that we are encountering in between this and this prefix sum, they has a sum of 0, because then only it's possible that a sum is repeating itself. If we will have a sum in between them which is not 0, then in that case this prefix sum would not have been 1, right? It would have been either greater than 1 or it would have been either lesser than 1. Okay, it wouldn't have been 1. So whenever a prefix sum repeat itself, it means that the numbers in between them are contributing to a zero sum. So let's verify that whether it's true. So you can see that where we got this prefix sum 1, we got this from here, and this prefix sum 1, we got it over here. So you can see that the elements after this 1, that is this 2 and this -2, are having a sum of what? These two are having a sum of 0. So here what we had 1 and we got a 1 over here. And since these two are having a sum of 0, so 1 plus this 0 is giving us a prefix sum of 1, right? So it's clear that here we are getting a part of a linked list that is having a zero sum, then only this one is repeating itself, correct? So how are we going to identify the part of the linked list that has a zero sum? We are going to identify this using prefix sum, right? Using prefix sum. So how by using the prefix sum? So whenever a prefix sum will repeat itself, it means that we have got a zero sum, right? Let me write it over here. Whenever a prefix sum, let me write it as PS. Whenever a prefix sum repeat itself, it means that we have got a part of linked list, that has a zero sum, correct? So we are done with the first part, which is identifying the part of linked list that has a sum of 0. Now the second part that we are yet left is how are we going to remove it, right? So you can see that this part is the one which is having a zero sum. So how we can remove it? We can remove it by setting the next of 1 as 4, correct? Now you may notice that how are we going to know that the prefix sum 1, this prefix sum which is repeating itself, where we have found it earlier, right? We found this one earlier, then only we are saying that we are having a zero sum, correct? So how are we going to know that we have got this prefix sum earlier? So for that, we have to keep track of this prefix sum. So we will be storing this prefix sum. Additionally, we have to know one more thing, that for which node, that at which point in this linked list we are getting this prefix sum. So for that, what we will be doing is we will be using a hash map. And in that hash map, what we will be storing is, we will be storing the prefix sum, and corresponding to prefix sum, we will be storing the node. So say for example, if we store the prefix sum as 1, then this prefix sum 1 is corresponding to which node? It's corresponding to the node 1, correct? And similarly, we will store this prefix sum 3, and corresponding to it, we will store the node 2. And the moment we will get this prefix sum 1, so what we will do, we will check that whether this prefix sum 1 is already present in our hash map. So we can see that this prefix sum 1 is already present in our hash map. So what does it mean? It means that in between this, whatever the numbers are present, they are giving us a sum of 0. So we have to delete those nodes. So how are we going to delete those nodes? We are going to set the next of this node. That is, whatever the prefix sum which is repeating itself, we will find out its corresponding node, which is 1, and we will set its next to the next of this -2. So what we will set? We will set the next of this 1 as the next of -2, which is nothing but 4. Okay. So, and we will be getting the result as 1, 4, correct? So now we have identified the part of linked list that has a sum of 0, and we have also removed it. Okay. So we are done with both the steps. Now, before moving to solving this example, I want to discuss one more test case with you. So let me write it over here. If we have 1 minus 1, so what should be its result? Its result should be null, right? Why? Because you can see that this 1 plus minus 1, what is the sum? Its sum is 0, correct? So this entire linked list is having a sum of 0. So it means that we have to delete the entire linked list, and if we will delete the entire linked list, what would be our result? It would be nothing but null. So let's see that whether the approach which we discussed over here is going to work on this or not. Okay. So initially we are present at this node, and let's say this is our hash map which is initially empty. So what we will do, we will store the prefix sum as 1 and the corresponding node as 1, correct? Now we will come over here. What would be our prefix sum? Our prefix sum would be 1 plus minus 1, which is what? Which is 0. So we will check that is this 0 present in our hash map. So 0 is not present in our hash map. So what does it mean? It means that we have not got any 0 sum. So what we will do, we'll simply store this prefix sum and its corresponding node as -1, and we will move forward. And you can see that we have completely exhausted the linked list. So according to this approach, what would be our result? Our result would be this linked list only. But is this correct? The answer is no, it's not correct. So for handling these kind of test cases in which we have to delete the head or in which we have to delete the entire linked list, what we will be doing is we will be using a dummy node. Let's say the dummy node value is 0, and what we will do, we will set the next of this dummy node as the linked list which is given to us. And what we will do is, in the hash map, initially we will store this dummy node. So our dummy node is 0, and initially what was our prefix sum? It was 0. So we will store the prefix sum 0, and corresponding to it we will store this dummy node. Okay. Now again let's do the same dry run. So what would be the prefix sum over here? It would be 0 plus 1. So what would be it? It would be 1. So we will check, is this 1 present in our hash map? So this 1 is not present in our hash map. So we will store the prefix sum 1, and corresponding to it we will store the node 1. Now we will move forward. So we have got a -1. So what would be the prefix sum? The prefix sum would be 1 plus -1, which is 0. Now we will check that is this prefix sum 0 present in our hash map. So you can see that this prefix sum 0 is already present in our hash map. So what does it mean? It means that we have got consecutive nodes that has a 0 sum. So what we have to do? We have to now delete it. So how are we going to delete it? We are going to set the next of this 0, right? We are going to set the next of this node, that is the next of this 0, as what? As the next of this -1. So what would be its next? Its next would be null, correct? So what we have got? We have got 0, and corresponding to it is what? It's null. So we have got this till now. Now what we will be returning as the answer? We will be returning the next of this 0 as the answer. Why? Because this 0 was not initially part of the linked list, right? This was not the part of the linked list. We made this dummy node on our own so as to handle these kind of test cases. So what we will be returning is, we will be returning the next of this particular dummy node. So what is the next of this dummy node? The next of this dummy node is what? It's null. So what would be our answer? It would be null. So is it working now? So yeah, it's working. So we have to keep in mind that just after creating the hash map, we have to store the prefix sum 0 and corresponding to it the dummy node. Okay. So now that it's clear, now let's do a quick dry run for this test case. So let us create a hash map over here. And what we will be storing in the hash map, we will be storing the prefix sum and corresponding to it would be the node. Okay. So after that, what we have to do, we have to create a dummy node. Let's say this is our dummy node. Let's say this is dummy. And we have to set the next of the dummy node as the head of the linked list. Okay. Now let's create a pointer current, which would be at the head of the linked list. And initially what our prefix sum would be 0. Prefix sum would be 0. Fine. Now what we have to store in our hash map, initially we will be storing the prefix sum 0 and corresponding to it we will store the dummy node. What is the dummy node? It's 0. Okay. So now our current pointer is at 1. So until our current is not null, what we will do? We will find out the prefix sum. So what will be the prefix sum? It would be 0 plus 1, which is 1. So now what we will do? We'll check, is this 1 present in our hash map? So this prefix of 1 is not present in the hash map. So what we will do? We will store this prefix of 1 and corresponding to it, we will store the node. So what is the node? It's 1. And now what we will do? We will move forward. So let me represent this current with C. Okay. So we are here. So this is current. Okay. So let me write this as well as C. Okay. So now we are here. Now what would be the prefix sum? The prefix sum would be 1 plus 2, which is 3. Now we will check, is this 3 present in our hash map? So 3 is not present in our hash map. So what we will do, we will store this prefix sum, that is we will store this 3 and its corresponding node. What is its corresponding node? It's 2. So we will store this 2. Now we will move forward. So what would be the prefix sum now? It would be 3 plus 3, which would be 6. Now we will check, is this 6 present in our hash map? So 6 is not present in our hash map. So what we will do, we will store this prefix sum 6 and its corresponding node. So what is its corresponding node? Its corresponding node is 3. Now again, we will move forward. So what would be the prefix sum now? It would be 6 plus minus 3. That is 3. Now we will check, is this 3 present in our hash map? So we can see that 3 is already present in our hash map. So what does it mean? It means that this particular prefix sum is repeating itself, which means that the numbers in between this prefix sum to this prefix sum has a sum of 0, correct? Then only it's repeating itself. So we have identified the part of linked list that has a sum of 0. Now what we have to do? We have to remove it. So how we will remove it? We will set the next of this 2. Where is this 2? It's here, right? We will set the next of this 2 as the next of the node where we are getting this 3. So where are we getting this prefix sum 3? We are getting this prefix sum 3 at here. So we will set the next of this 2 as the next of current, which is this minus 2, right? And let's verify whether we are getting a part that has a 0 sum or not. So here you can see that what we are having 3 and minus 3. And what would be its sum? Its sum would be 0, right? So since we have got a part of the linked list that has a sum of 0, so we have to delete it. But one more thing we have to notice over here is that before deleting this part, what we have to do is we have to also remove the prefix sum which we have found out for these nodes. That is this one. So how we were getting the 6? We were getting the 6 by adding the prefix sum which we got till here plus this 3, right? And since we will be deleting this 3, we also have to delete this entry, right? So what we will do? We will delete this entry. So we will delete this entry, okay? And after deleting this entry, what we will do? We will set the next of this 2 as the next of this current. So what will happen? We will set the next of this 2 to the next of current. So what is the next of current? It's minus 2. And we have successfully deleted this part. So what would be our resultant linked list? It would be like this. Okay. And now our current will point over here. Fine. So what would be our prefix sum now? It would be 3 plus minus 2, which is 1. Now what we will do, we will check whether this prefix of 1 is already present in our hash map or not. So is 1 present in our hash map? So we can see that this prefix of 1 is already present in our hash map. So what does it mean? It means that the elements in between them has a sum of 0. So what we have to do? We have to remove them. So let's check whether this is true or not. So you can see over here that we have a 2 and here we have a -2. So what would be its sum? Its sum is 0. So we have got consecutive nodes with sum 0. So now let's remove it. So how are we going to remove it? We are going to set the next of this one. So where is this one? It's over here. So we are going to set the next of this one as the next of current. What is the next of current? It's null. So we will set the next of this one as the next of current, which is null. So what would be our resultant linked list? It would be like this, right? So let me write this clearly. So it would be like this. The next of this would be null. Now again we will move our current. So our current will reach null and we will stop. So this is what we have got. Now what we have to return? We have to return the next of this dummy node. So what is the next of the dummy node? The next of this dummy node is this. That is, it's only 1. So our answer would be 1. So I hope it's understood to you all. So now let's quickly code this. Let us first create the dummy node. So let's take the value of the dummy node as 0. Now what we have to do, we have to set the next of the dummy node as the head. And we have to create a pointer that we will use to iterate over the given linked list. So let's take that pointer as current and it would be initially pointing at head. Okay. Now what we have to do, we have to create an unordered map and what we will be storing in it is the prefix sum and the corresponding node to it, right? So let's name this as memo. And what we will store the prefix sum and node, correct? So initially our prefix sum would be what? Initially our prefix sum would be 0. And what we have to store in our hash map? Initially we have to store this prefix sum of 0 and corresponding to it we have to store the dummy node, right? So as to handle test cases like this. If we have a test case like 1, -1 in which we have to delete the entire linked list. So for this, for handling this test case, we have to store this one, right? Now what we will be doing is until our current is not null. What we will do? We will find out the prefix sum. So what would be the prefix sum? Prefix sum would be prefix sum plus the current node's value. The current node's value, correct? After finding out the prefix sum, what we have to check is we have to check whether this prefix sum is present in our hash map or not, correct? So we will check that if memo of prefix sum, correct? Prefix sum. If this prefix sum is already present in our hash map, then we will do something and otherwise we will do something, right? So let us first handle this else. So if our prefix sum was not present, then what we were doing, we were simply adding the prefix sum and its corresponding node, correct? So in the else part, what we were doing, we were adding the prefix sum. We are adding the prefix sum and its corresponding node. So what is the corresponding nodes? It's current, correct? Now let's handle this if case. So if our prefix sum is present, then what does it mean? It means that we have found out the zero sum, found out a part that has zero sum. So what we have to do, we have to remove it, correct? So how are we going to do it? So let's say list node star from. So let's take this from as memo of prefix sum. Now what is this from? So let's see over here. So if we had a linked list like this, so here you can see that whenever this prefix sum was getting repeated, so what we were doing, we were deleting this part, that is we were setting the next of this 2 as this -2, right? So what would be this from? This from would be nothing but this 2, right? This from would be nothing but this 2. So from this node, what we have to do is let's take another node 2, which would be the next of from. And let's say that sum is equal to, it would be the current prefix sum plus the value of this node, right? Now what are we doing over here is we are deleting this entries. We were deleting this entry, right? We were deleting the prefix sum for the part which we are deleting. If we will delete this part, so what we have to do? We have to also delete the prefix sum which we have found out for this part, right? So now what we are doing? We are deleting this. So we will say that while this sum is not equals to the prefix sum. So until that time. Until that, what we have to do? Until that, we have to erase this sum. So we will erase this sum, and after erasing this sum, we will set 2 as the next of 2, and we will update our sum as sum plus equals to the value of 2. Okay. Now what we will do? Now, once we have deleted this sum from the hash map, what we have to do? We have to delete this part of the linked list. And how we will be deleting this part? We will be setting the next of this from to the next of this current, right? That is, we will set the next of from's next as current's next. Fine. Now, once we have handled this if case and this else case, what we have to do? We have to simply increment our current pointer. So current is what? Current is current's next. And after doing this, what we have to do? We have to finally return the next of this dummy node, right? We have to return the next of the dummy node. Now let's quickly run this. So it's giving us the correct answer. Let's submit it. So it got accepted. Talking about the time complexity and space complexity. So if we will have a total of n nodes in the linked list, then the time complexity is order of n. Why? So here you can see that what we are doing. Here we are completely iterating over the entire linked list, right? So what does it mean? It means that we are processing all the n nodes. So the time complexity here would be order of n, correct? And the space complexity is order of n as well. Why? Because here what we are doing is in the hash map, we are storing the prefix sum corresponding to all the n nodes, right? So the space complexity would also be order of n. So that's all about today's daily LeetCode challenge. Thank you.